Today, I'm just going to skip the general introduction about the Webb and go directly into today's subject. We also need to understand that the Webb telescope's findings are pushing the boundaries of our current astronomical theories, and as we speak, it's on the brink of revolutionizing our understanding of nature and its workings. Scientists explain that recent observations from the Webb have uncovered something unexpected in the early universe, challenging scientists globally and suggesting that what the Webb telescope found may be a major problem for our standard model. In an unprecedented discovery, astronomers have spotted a mysterious structure located deep in the universe.
If you're in any doubt about how significant these new images are, I wish you could be in this room, because around me are the scientists, the astrophysicists, the cosmologists who really understand how they've changed our view of the universe.
Non-stop expansion ever since. However, we all know that the 13.8 billion years age of the universe is wrong, so just bear with me for the sake of this discussion. When talking about expansion at the beginning of the universe, it means that massive objects are moving away from each other. This indicates that the galaxies we observe outside our Milky Way are moving away from us. To measure how far a galaxy is from us, we use something called the cosmological redshift. In a nutshell, the higher the redshift, the farther away a galaxy is from us. Light from distant galaxies takes a lot of time to reach us, implying that the more distant a galaxy is, the earlier in time we see it. However, there is a problem. Light from galaxies far away stretches into infrared wavelengths, which the human eye cannot detect. The Hubble Space Telescope can only observe ultraviolet to near-infrared light, which is why it rarely found extremely distant galaxies, with GN-Z11 being one of them. GN-Z11 is shown as it existed 13.4 billion years in the past, just 400 million years after the Big Bang. This galaxy has a redshift value of 10.957, leading astronomers to believe there were very few galaxies beyond redshift 11. Here comes the James Webb Space Telescope, which can see in infrared, enabling it to detect objects at redshifts 11 and above. When the telescope was launched and pointed towards the heavens, a very different picture of the universe started to emerge from the depths of time. The telescope revealed dozens of galaxies that could be among the earliest known in the universe. Using early observations, astronomers looked for galaxies at very high redshifts, indicating they formed earlier in the universe than expected. NASA detected several galaxies that may have been the first to appear in the universe about 200 to 300 million years after the Big Bang. Soon, the telescope discovered the oldest galaxy in the universe, the Galaxies Z13 galaxy, at a redshift of 13.2, formed just 300 million years after the Big Bang. Finding such a large number of galaxies in the early universe suggests we might need to revise our previous understanding of galaxy formation. The lead astronomer at the University of Missouri stated that their findings give the first indication that many galaxies may have formed much earlier than previously thought. While this discovery shook the scientific community, another primordial galaxy emerged, existing only 390 million years after the Big Bang. In recent weeks, we've learned about groundbreaking discoveries by the Webb telescope that challenge our understanding of how distant galaxies formed shortly after the Big Bang. People are intrigued by the surprises coming from the Webb telescope. First, they admire the beautiful pictures and ask what new information they reveal. The big answers are that the first galaxies grew differently than expected, and we don't know why previous predictions were wrong. Adding to these discussions, the James Webb Telescope has made another significant discovery in the early universe. The MIRI European Consortium GTO team recently announced the detection of an extremely red object that most deep NIRCam surveys missed. They found this object while searching for faint sources in the new images received from the telescope. Faint sources are essential because the Webb telescope captures less light from distant objects, causing them to appear faint and red in its images. While searching, the team stumbled upon an extremely red object that previous surveys couldn't detect. Scientists believe this object could be one of the most distant ever found. Occasionally, nearby objects appear faint due to dust clouds, but the team ruled out that possibility. The object appears extended and has remained in the same position for a year, leading scientists to dismiss the idea that it's a brown dwarf in our galaxy. Currently, scientists don't know what the object is, but they've proposed 3 possible explanations in a new research paper. Initially, researchers suggested it could be a dwarf galaxy with abundant dust located approximately 4 to 5 billion light-years away. However, further investigations made this explanation less likely. Another possibility was a distant dusty galaxy that existed 1 to 2 billion years after the Big Bang, but this too seems improbable. The third explanation has garnered significant attention, with scientists expressing more confidence in its validity. They propose that the object could be a galaxy sharing characteristics with the small red dot galaxies recently discovered by the James Webb Telescope. Remarkably, this red galaxy is positioned at a redshift of 15, indicating its existence just 100 million years after the Big Bang. If this explanation holds true, it would mark the oldest and most distant galaxy ever observed, challenging our understanding of the universe. The discovery of these minuscule red dot galaxies has already confounded scientists because they are much more massive and luminous than anticipated by current models. Now, the revelation of another object even further away threatens to disrupt the standard cosmological model, posing a significant challenge to our comprehension of the universe. Moreover, recent findings have presented additional evidence against the standard cosmological model. According to conventional norms, galaxies were not expected to form so early. However, a newly discovered galaxy dating back roughly 13 billion years appeared long before the expected formation process involving giant halos of dark matter. This early distant galaxy contains more stars than the Milky Way, despite forming only 800 million years into the universe's 13.8 billion year lifespan. This suggests that these galaxies somehow formed without dark matter seeding their formation, contradicting the standard model of galaxy formation. Scientists are now questioning how this is possible. How a galaxy could form without enough dark matter to trigger the galaxy formation process in the early universe. Claudia Lagos, an associate professor of astronomy at the International Center for Radio Astronomy Research, says that having these extremely massive galaxies so early in the universe is posing significant challenges to our standard model of cosmology. This is because massive dark matter structures, thought to be necessary components for holding early galaxies together, did not yet have time to form this early in the universe. To understand how these galaxies came into existence so early in the universe, we'd have to delve into what occurred before the Big Bang. In conclusion, current efforts in this direction are mere speculations. Some theories propose supernatural elements, such as a designer, while others remain within the realm of physics, like the concept of a multiverse, which encompasses an infinite number of parallel universes, or cyclical models of the universe where it undergoes repeated cycles of birth and rebirth. Nobel Prize-winning physicist Roger Penrose, in contrast, presents a fascinating explanation for these massive early galaxies. In his theory, he discusses the existence of another universe before the Big Bang. Although this idea is currently controversial among cosmologists, Penrose's perspective is intriguing for philosophers of science. It introduces new avenues for understanding the Big Bang, transcending ordinary cause and effect explanations. Thus, it serves as a significant test case for exploring the various ways in which physics can elucidate our world, warranting further attention from philosophers. With the Webb telescope approaching the final year of its science operations, scientists anticipate more extraordinary discoveries that can shed light on why, how, and when our universe came into existence.